A while ago, I explored Komodor and concluded that it is probably one of the best, if not the best, tool for Kubernetes troubleshooting. Now, over a year passed since then, and Komodor has evolved a lot. So, today I'm giving it a second try. Is it still a recommended tool for Kubernetes troubleshooting? What are the new features? Should you use it in your organization? And a few more things. Let's find out. For those of you not familiar with Komodor, it is, at least from my perspective, first and foremost a Kubernetes troubleshooting tool, or at least that's how it started. Today it allows us to do much more, so much more. We can use it to monitor our clusters and to send alerts triggered by specific events. It shows us the differences between the current state and the previous states. It guides us towards applying best practices. It shows us the events that happened in a cluster. It allows us to edit and scale our applications, and so on and so forth. If Komodor was a great tool for troubleshooting, let's see whether all the new features make it even better. So we'll start by exploring services. Let me start by deploying a silly demo application that we'll use to see how Komodor works with my applications inside of my cluster. So I'm going to execute kubectl, namespace is production, apply whatever is defined in the case directory. Simple. This is the Komodor web UI, and I'm in the services section, and I would like to see what's happening with the application I just deployed. It is one of the, in my case, 37 services that I have over there. And to simplify how things work, I'm going to specify, actually to filter the services to show only those that are in the production namespace. Over there is only one application, one what Komodor calls a service, which is misleading because services in Kubernetes have a very different meaning. But nevertheless, we have services, and I can see that there is only one silly demo. So let's see what's happening with that service right now. There were some availability issues early on. That's normal because it takes a couple of moments until the application is up and running and healthy and scaled up. That was resolved. You can see that it says closed in the right hand column, and now my application is up and running. You know it's up and running because it's green there in the dashboard. If you click the deployment itself, I can see the status, what's going on right now, what is the current status, actually what is the status in that moment in time, not the current one necessarily always. I'll get back to the details later. For now, I want to make an intentional mistake, do something silly as a way to simulate what would happen if there is an issue in my cluster with one of my applications. So let me do the diff of the case deployment manifest. That's the one that I'm using right now, and deployment bed, that's the one that I will use in a moment or two. And you can see that the tag is, this tag does not exist. The name of the tag tells you everything. I'm going to deploy an application based on an image tag that does not exist. And if that does not trigger some warnings, nothing will. So let's see what happens if I make a mistake. Now it's intentional, but in real life, it won't be. So I'm going to execute kubectl, namespace is production. I want to apply whatever is defined in deployment bed YAML. And then I'm going to go back to Komodor and see what's going on. What will it tell me? We can see that there are some new events and that I can click the link to update. That's kind of silly. It should just update. Of course, I want to see the latest events. Maybe it's demanding on CPU memory or something like that. Anyways, let's see what is that new event that just came in. And so far, it looks good. The deployment of my new release just started. There are no red flags, nothing wrong for now. And then, look at that. A few moments later, it failed. It takes a bit of time until Kubernetes realized that it cannot pull the image that doesn't exist. It tried, it failed, and now I can see in Komodor that there is something wrong with my deployment. It says failed, and I can go and see the details of that deployment to see what's going on, what's the potential issue. Imagine that I do not know what I did, even though I did it. Anyways, let's see the details. Let's see what will find out. And this is where troubleshooting starts, right? There is something wrong. I go to details and I can see quite a few pieces of information that will hopefully help me deduce what's wrong. There is the error message. Obviously, the system cannot pull the image because it doesn't exist. There is an explanation with possible causes of that issue and how we might be able to fix it, which could be very, very helpful. We could roll back to the previous release straight from the UI, which could be helpful or dangerous depending on what you're doing, right? If you have some kind of automation, if you use GitOps, let's say, please do not roll back from this UI. And if you use some other type of automation like CI/CD pipelines, Jenkins, GitHub Actions, whatever you're using, again, do not do it this way. Anyways, if you're keeping your manifest in Git, do not roll back like this. That's not a good idea. You should push changes to Git and then allow your processes to do it. But some people do not have any sort of automation, and then for those types of people, you can either roll back from here or just do better. Don't do it without automation. Anyways, you can roll back, but you shouldn't. Further on, we can see the events that happen to that pod, and through those events we can deduce the order of things that happened and why what happened, and so on and so forth. Very useful. We can see the differences between what was there before and what is there right now. What you see in the details page without clicking any links is actually very useful. We can see that, hey, this was the previous image and this is the current image. That's probably what's wrong somehow. And then we can see the full diff. Now, diff is great and not so great at the same time. It shows us the differences between the previous state of the resource and the current one, which is great. I can see that there are differences in the image that could be the cause of the issue, but then it shows me the differences between runtime information injected by Kubernetes itself, which is noise. This shouldn't be there. Komodor shouldn't just blindly apply the differences between two resources in Kubernetes because they are enriched with Kubernetes information that is most of the time not relevant. It should show me by default the differences between what I applied before and what I applied now without Kubernetes specific runtime information, at least by default, because that just produces noise that distracts me from figuring out what's wrong. And then we have the GitHub section that is empty right now. And if you click on that link, we get the instructions how we can enrich our manifests so that Komodor knows from which Git repository, which commit, and which file directory information comes from where the manifests come from. But I'll comment on that later. I think that this feature is silly for most of the users, so I'll get back to it later. And finally, there is the link section if you want to add additional links. Now, everything I showed so far is related to the events of a specific service. We have also a couple of other sections like pods. I can see all the pods related to this application, which is great, and I can see the nodes where that application or the pods of that application are running. That's also great. And we have additional information about a specific service. Don't call it service, application. Now in that info section, there is an interesting, maybe hidden a bit feature, and that's best practices. I can go there and see that I have one warning. So let's see what are all the best practices and what is the warning, what is the thing that I might want to improve. Everything seems to be fine, except that pull policy is not set to always. That's the only warning, and that makes sense. I should always set the pull policy to always, at least by default, unless I have a special need not to have that policy applied. I should. Anyways, let's see what's the description of that warning. I have information about what is checked and why that is checked, and I should now go and fix that. I will not do that in this video. What I will say is that I would like to see some kind of a snippet. Okay, so this is the problem. This is the best practice that you're not implementing. How about you inject this into the deployment? Because I already know that you have Kubernetes deployment. I already know what it is. So why don't I give you a suggestion of what you should do? That would be awesome. So don't tell me about the problem, only tell me how to solve the problem in an intelligent way. An intelligent way is just to show me the snippet within my manifest. Now let me apply the good version of the application, and then we go to the next section. Let's talk about monitors. But first, let me execute kubectl namespaces production. I want to apply whatever is specified in the directory Kate and put my application back to the correct state. Effectively, what I'm doing is rolling back, but in a good way, not through the UI. We'll get back to that later. Now let's talk about monitoring. If you go to the monitors section, we can see the monitors that are currently applied to my cluster. I'm interested in the cluster called dot, and right now I have only those monitors that come by default. There aren't many of them, 10, maybe 15, something like that. But what matters is not what comes out of the box, which is awesome, but that I can create my own monitors. I can create my own triggers that will show me the information when something goes wrong, depending on the conditions that I specify myself. So I'm going to click the add rule within the availability monitor, and then I'm going to create my own rule. I like creating my own stuff. As trigger conditions, I will say, so actually let me explain first what I want to accomplish. I want to create a rule that will be triggered, the alert will be triggered if I have less than 2 replicas of an application in a specific namespace, because I care about the production namespace right now. So how would I do that? I will say that the trigger conditions are a number, not a percentage, and that condition will be triggered in the number of replicas is smaller than 2. Less than 2 replicas, meaning 1 replica effectively, or maybe 0. And this trigger will go into effect only if it is active for more than 30 seconds. So I do not want false positives like, hey, something was bad for a second or 2. So what I really care here is to find out if something did not scale up an application in the production namespace for more than 30 seconds. And since we're talking about production, I'm going to change from cluster to custom scope. I'm going to select namespace production, and I want the alerts to be sent to my Slack workspace inside the namespace, how do you call it? Channel, I think, tests. And that's it. I can save the monitor, and from now on I have additional monitor or alerting system. So let's create conditions that will generate an alert under those conditions with those rules. As before, I'm going to show you the differences between the manifest I'm using right now and what I will deploy. And the difference is in the number of replicas. Right now I have 3 replicas, and I want to have an application with 1 replica. Intentionally never do this in production. Anyways, I want to have 1 replica so that I can show you how this trigger works. So I'm going to apply by executing, kubectl namespaces production. I want to apply whatever is defined in the file name deployment 1 replica YAML. And then if I go back to services silly demo, I should not see anything right now, except that the deployment updated, because I need to wait for 30 seconds approximately. And this might be a great time while waiting for you to, what should you do? Yes, like the video and subscribe to the channel and join the channel if you can afford it, and tell your boss if you work in a software company to sponsor the channel. Thank you so much for this. And now we can see the effect of the monitor. And now there is an availability issue over there. So the trigger that I created just fired approximately 30 seconds later, 30 seconds after it discovered that there isn't sufficient number of replicas. And if I go there, I have checks and findings with information. Sometimes Komodor gets confused. Right now it is telling me that it found 0 pods and it wants 1, which is not correct. There is 1 pod and there should be more than 1 pod, but this is probably a temporary bug that will be fixed soon. Now monitor view is potentially interesting. Over there we can see the view with all the monitors that are currently set up within this section, and which ones of them are executed and which ones of them are working correctly, which ones failed. So it's a graphical representation of all the monitors and all the triggers, which is potentially nice. Now if I go to the info section, I should have two best practices violated, right? Before I had only one, and now I should have the best practice that says run more than one pod, one replica. So let's see whether that's really the case. So I'm going to the info, and indeed there is best practices 2 warnings right now. And if I go to the list of best practices, I can see that the deployment has only one replica, and that's bad. That should be fixed. Again, I'm not getting a snippet, I'm not getting much help how to fix it, what I should do, but what I do get is the violation of one of the best practices. I should fix that. I mean, I intentionally unfixed it, right? But I'm pretending that I'm simulating failures here. I'm not pretending to simulate, I am simulating failures. Now, how would I fix the issue of not having enough pods? Now, the newbie would say, hey, just specify the number of replicas if in your deployment, which would be correct, but a silly thing to do. I'm going to fix it in a right way, or at least a better way. So I'm going to scale my application by deploying horizontal pod autoscaler. And what I want to do with that, or to check, is how Komodor behaves on 2 fronts. First of all, whether it will detect that my application scaled to multiple replicas. Second, whether it will discover that the number of replicas in the Kubernetes deployment changed, not because I changed the deployment, but because I applied horizontal pod autoscaler, which will change it for me. So very simple, still slightly more complex scenario, and I want to see how Komodor deals with it. So let's take a look at the famous HPA YAML, and there is nothing special here. I'm just saying, hey, I want minimum of 2 replicas, maximum of 6 replicas, and they should be applied to the deployment called silly demo, and the target CPU utilization percentage 80%. This is a silly demo, it will not work, but it will, because I would need to simulate CPU usage, but as a result of this, it will scale my application to minimum of 2 replicas, so it should immediately fix the issue. So let me apply this by executing kubectl, namespace is production, apply whatever is defined in HPA YAML. Now if I go to services and silly demo and wait for a couple of moments, I can see that the deployment is now green again. It changed the number of replicas, but in this case, Komodor continues freaking out and says now we have plus 13. We don't have plus 13 replicas, but the issue was fixed. I can go to pods, the list of pods, and see that, yeah, there are 2 pods now, so the issue should be fixed. And if I go to info and the best practices, I can see that only the one about the pool mechanism prevailed, and the one that was complaining about the number of replicas is there, it's fixed, it's green. But Komodor does not know how it got fixed. It thinks that I modified the number of replicas of my deployment, which is not the case. I applied HPA, horizontal pod autoscaler, which did that for me. So it is showing me the manifest with the deployment, which is fine, but it should show me the HPA as well, because that's what fixed this best practice issue, and at the same time the trigger, the monitor trigger that I created myself. Now let's go back to the details of the application of the service silly demo, and over there is the scale button. Now you might be tempted to use that button. You might click on it and change the number of replicas, in this case from 2 to something else, but please don't do this. This is very dangerous. This is a dangerous feature. This is good only for people or teams that are using the most basic Kubernetes setup ever, because Komodor thinks that I specified 2 replicas of my deployment, but I did not do that. HPA did that. And if you would change the number of replicas here, it would modify the deployment, and that would work for a couple of seconds, and then your change would be undone by HPA, and this is very dangerous. It's very dangerous to modify resources through Komodor or any other similar tool without really understanding what you have in your cluster. So beware before you use this feature. Another useful feature of Komodor is to see all the events happening in your cluster, and you can do that by, surprise, going to the events link on the left hand menu, and there you can see all the events that happened inside my cluster. So in the events page, we have all the events of everything happening in a cluster, which is very useful. We can filter it in different ways, and that's also great. You can see that my cluster started with a lot of issues, but they were resolved, which is normal. At the beginning, cluster needs a bit of time until it settles down. And we can go to any of those events, see the differences between the changes performed before the event and after the event, and so on and so forth. Very, very useful. I mean, you have to go through Kubernetes events one way or another, and why not going through them through Komodor? Now, one thing that many similar applications struggle with, and I think is very important, and that's the way how they handle custom resources. And now you might be saying, hey, custom resources is not something that I use. I'm not creating my own operators and controllers and CRDs, but that might be true. You're not creating your own, but your cluster is running almost certainly a bunch of custom resources, and I want to know how Komodor deals with those. And to demonstrate that, or to double check that, I'm going to use one of the projects that you're likely using yourself, which is Argo CD, or if you're not using Argo CD, you're probably using Flux. Anyways, I'm going to delete the application that I deployed manually, and then I'm going to deploy that application with Argo CD and see whether Komodor will be able to deal with that. So everything goes out, Argo CD comes in. I'm deleting my application by executing kubectl namespace production delete whatever it was defined in the directory Kates, and I'm deleting the HPA resource as well, the one that both of those I deployed manually. And then we're going to take a look at Argo CD manifest that will automate the deployment of my application, which is how I should be doing it in the first place. So cut Argo CD app YAML, and this is a typical standard Argo CD application. There is nothing special about it. It says, hey, whenever there is something in the directory Kates of the repository Komodor Demo 2, you should synchronize it. Easy, right? We like easy. So I'm going to apply that manifest with kubectl apply. File name is Argo CD app YAML, and from now on I will not be deploying my application. I'll be pushing manifests of my applications to Git repository, and Argo CD will synchronize them. Great, but Argo CD is not the main subject of this video. I'm interested in Komodor and finding out whether it can deal with what I just did. But before I do that, let me go to Argo CD, log in, and double check that it's working. And yes, you can see that Argo CD deployed my application with all the resources that they have. Okay, so I'm going back to Komodor, back to silly demo, and we can see that I got a new deployment. Great. Komodor detected a deployment. It doesn't care really whether I did it with Argo CD or by executing kubectl apply. And I can go to details, and you can see that Komodor detected quite a few differences, namely related to annotations and labels. That's what Argo CD added to my deployment. Great. And here comes the interesting part, right? It is telling me still, hey, you should add Komodor specific annotations so that Komodor can discover what is the relation between your manifests and your Git repository. And you might say, great, I'm going to do that. But I say, don't. And let me explain why I'm saying don't do that. Komodor should do it for you, or figure out how to do it if it cannot do it right now. Let me demonstrate why. By executing kubectl namespaces Argo CD, I want to retrieve the application called app and output it as YAML. It's very important. What's inside of this Kubernetes application running in Kubernetes cluster is critical for what I'm going to show or say or prove. Now let's take a look at status and then sync section, and within that section there is compared to, and over there is source, and inside source there is repo URL, right? So it is discoverable. What is the Git repository related to this Argo CD application is discoverable because the information is in that manifest. And even though target revision is head, meaning whatever is in the main line, the last commit of that branch, the revision gives me the specific commit that was used to apply this manifest. And that means that if Argo CD has that information, then Komodor can fetch it from there. And you might say, hey, but this is Argo CD application, not my application. But my application is a child resource or child resources of Argo CD application. So you could, through parent-child relationship, discover what are all the resources related to this Argo CD application. This Argo CD application right now is related to this specific commit. So what I'm trying to say is that GitHub information is discoverable. And if it is discoverable, then there is no good reason why I would add additional annotations for something that already exists. It's already discoverable. So what I'm trying to say is quite a few things. And the first one is that GitHub integration Komodor demands too much work. There is no point for me adding Komodor specific annotations if I'm using GitOps tools like Argo CD or Flux or even Rancher Fleet, since at least part of that info, like GitHub repository, is already available at runtime through the resources of those tools. Now, even if I ignore GitOps and say I'm not using GitOps, which would be silly, then those annotations would make some kind of sense if there would be some sort of a standard. If I'm to put those specific annotations specific to Komodor into my manifest, I would probably have to do or add similar annotations and labels for other tools as well. And I do not want to do that. I do not want to have 5,000 annotations and labels in my manifest because I have a bunch of tools that might need them. And each of those tools want a different format. Silly, I don't want to do that. So Komodor should do one of the two things. First, discover if any existing resources in my cluster have the information it needs to discover the Git repository that it is associated with those resources. And if that's not the case, then start a Kubernetes SIG or special interest group, if one doesn't exist already, to create extended standard annotations. I do not like the idea of using Komodor specific annotations in my manifest, knowing that Komodor is one of the many tools that might force me to do that. And I don't want to do that, especially when information is discoverable. So let's go back to Komodor Web UI and see what else we can discover. I already commented how scaling, the scale button, is dangerous at best. So I urge you not to use it unless you're really doing everything manually, or in cases of breaking glass situation, right? Kind of, oh, danger, danger, I need to fix it immediately and I do not know how to use kubectl. Now, the same thing can be said for other operations in Komodor that allow us to modify the resources at runtime, like edit YAML. Don't use it if your manifests are in Git and you have some sort of automation, GitOps or pipelines to apply them. So those features, new features, at least compared to my previous review of Komodor, are dangerous at best. Now, the good news is that we can set up users in Komodor and say, hey, you can be an admin or you can be read-only user, and that can mitigate those issues somehow. What else do we have in Komodor? Well, we have, I'm going to call it resource browser because there is no name for this section in the menu that shows me the nodes and the workloads. And within workloads, I have pods and replica sets and deployments and so on and so forth, the standard things, the things that come out of the box in Kubernetes. Now, this is great, again, if you're using very simple out-of-the-box, not extended version of Kubernetes. The moment you start using something like Argo CD, you will not see it over there. If you start using something like Knative, you will not see that there either. So you will not see anything that is not basic Kubernetes type of manifest, those that come out of the box, because Komodor does not yet know how to deal with custom resources, which is disappointing. Nevertheless, within the workloads, we have different actions. We can fetch the logs or delete the workflow. Fetch the logs, great. Delete, not so great. Unless you actually deleting a pod is okay. It's a type of action that you should be able to do, because sometimes you might have a pod that is hanging, and pods are not controlled directly but through deployment, so it's okay if you modify those, as long as you don't modify deployments or other types of higher level resources. And then we have configuration, network, standard stuff, and CRDs. Now, CRDs is a mystery. I do not understand what CRDs mean in Komodor, because I do not care about CRDs. I do not care much about custom resource definitions, at least not from the troubleshooting perspective. I care about custom resources, not custom resource definitions. So this is just a list of CRDs, not very useful. Komodor, please give me the possibility to do stuff with custom resources because everybody has them. Now, the last part of Komodor I want to explore are integrations. And if you go to integrations, we can see that it integrates with commonly used tools like, hey, it can integrate with GitHub. We saw it. A bit unfortunate with GitLab as well, probably the same story. PagerDuty, we can add Kubernetes clusters, of course. We can integrate with Slack. I already did that, and so on and so forth. One possible, there are quite a few different interesting integrations. The one I want to check right now is the integration with Prometheus metric server. So I'm going to install that integration and see what we'll get. I need to give it the name, the address of the server. So I'm going to do that. It's internal address through the service of Prometheus itself, which is already installed in my cluster. And I'm going to install the integration. So let's see what we'll get with that integration, for example. Now, if I go back to services and let's say back to CLI demo application, you will see there two new columns, one for CPU usage and one for memory usage. Now, this is Komodor getting information from Prometheus and showing it in its own web UI, which is awesome, absolutely awesome, because it shows that Komodor knows how to work with other tools one way or another, and we can extend and add additional or remove the fields from this view as well. Finally, the last thing, did I say the previous section was last? And then this is the last, I promise, is to talk about, only for a few seconds, about Komodor Pricing. It's not free, it's a service, it's a SaaS offering that you need to pay for, which is okay, because every project needs some kind of financing. The only question is whether the price is fair or not for you. That's up to you to decide. You have business and enterprise pricing. Check it out. Check out the pricing page. You should know that it's not free. That's the only thing I want to say, and you should check whether the price is right for you or not. After I recorded the material for this video, something new happened. And that something new is that Komodor released free forever plan. So if you want to try it out, there is no financial obstacle. You can get your plan for free, try it out. Let me know how it works. Now let's jump into the most interesting part, and that's pros and cons. What are the pros, what are the cons, and whether you should use Komodor or not. Now, let's start with negative things I don't like about Komodor. And the first one is that it does not replace alerting tools like Robusta, for example, nor it replaces Kubernetes explorers like Lens, even though it has features from both types of tools. But nevertheless, it could be useful to have these features alongside the primary goal of Komodor, which is troubleshooting, right? So Komodor, first and foremost, is about troubleshooting, but it does give us some form of alerting mechanism and some form of or way to explore Kubernetes resources. None of them are amazingly good, so you still need additional tools for alerting and exploring, but those additional features are nice. If you don't need something extra, you can still stick with Komodor until things start becoming really complicated. There is no support for custom resources, which is my biggest complaint, because there is no cluster without custom resources, whether you know it or no. Next, the idea to add links as labels or annotations to your manifest so that Komodor can detect where those manifests come from, like what is the Git repository or what is the tool that applied them, is great, but only as the last resort. Many of the tools already have that information, and Komodor should be intelligent and discover it instead of forcing us to write another set of labels and annotations. I don't see the point of having CRDs in the menu over there in Komodor Explorer or resource section. It's just a list of CRDs. What's the point of it? It is a waste of space. Next, there is no logical grouping of resources. So I would like to see something like, something similar to what Argo CD UI shows. Like, hey, this is your deployment, excellent, I know that. But now that deployment created those replica sets, and those replica sets created those pods, and those pods created those containers, because in Kubernetes, everything is based on some resources being parent resources of some other resources, which are child resources of that parent resource. So there is a tree of resources in Kubernetes, and Komodor is not really showing me in any meaningful way. Next, the edit button should exclude entries edit by Kubernetes itself. First of all, if I'm going to edit a manifest at runtime directly in a cluster, I should not be presented with entries edited by Kubernetes at runtime, because that's very dangerous and we should not see those. Those are internal to Kubernetes, or at least we shouldn't modify those. What else? Oh yeah, if I do give Komodor links or information about the Git repo, which I don't want to do, but if I do it, then I do not think that Komodor edit button or scale button should be working directly with the cluster, but with that Git repo, because if you ask me for a Git repo, then I assume that you will be pushing changes that you enable me to make back to that Git repo, but that's not what it does either. Then there is a complaint that Komodor does not really understand the relation between resources. I already complained about that, but that means that when it allows me to edit something without storing it in Git, and that something is a deployment and number of replicas in a deployment, and it doesn't know about HPA, it creates a whole mess around. And then whomever is the sysadmin or SRE in your company or DevOps person is going to be very, very mad at you. So those buttons to edit resources are very dangerous. And when I say dangerous, I mean dangerous, especially dangerous given that Komodor wants to know about your Git repository, but then it doesn't do much about it when editing resources. And finally, the last grunt is that there are too many predefined things in Komodor, and that's great, because having predefined out-of-the-box experience is always great because it's easy. But then there is no ability to extend that predefined look and feel and information available with something custom. I was complaining about custom resources, but that can be attributed to other things like, hey, I integrated with Prometheus. Wouldn't I like to actually bring some additional custom fields from Prometheus to Komodor? I would, but I can't. So enough about complaining. Let's talk about the good things. To begin with, Komodor is potentially best Kubernetes troubleshooting tool available today. It was a year ago when I reviewed it last time, and it still is. Now, those additional features are a bit shaky, but the core functionality, which is troubleshooting, is absolutely amazing. Next, we have integrations. That's a really, really nice addition. We had integrations before. Now we have more integrations, which is even better. We have improved, or to say it differently, better, actually simplified installation process, which is great. I didn't show the installation itself, but trust me, it is much better and easier than before. And finally, we have new UI. UI looks and feels a bit better than before. So those were nice improvements to what we had in the past. All in all, Komodor might be the best or one of the best Kubernetes troubleshooting tools available today. Now, in this video, I've been very, very, very harsh on Komodor, but that's not because I don't like it, I do, but because I think it's great. I think it's a great tool, and I want great tools to become even better. So I did my best to find things that could be improved rather than think of them as complaints, right? Komodor wants to expand its scope, which is great, go beyond relatively simple and straightforward troubleshooting, which is great, and now it needs to polish that expansion. All in all, give Komodor a try. Try it out. Let me know what you think of it, or if you're already using it, please let me know what you think of the improvements it made, or the future improvements that I suggested. What do you think about those improvements? Should Komodor folks implement them? Let me know in the comments. Thank you.